Thank you. Thank you so much. All right, thank you for having me. This is actually my inaugural South by Southwest, so I feel very privileged to be actually speaking that first year. So before I get too started, it's always fun to see from the crowd how many people have spat for us, not just in general. Oh, good, a healthy crowd. How many people love the health care that they're getting today? I saw a couple brief arms. Okay, so I'll go into a little bit about why I started 23andMe, and then, or why we started 23andMe, and then about the product. So when I graduated from high school, or graduated from college, I randomly got a job on Wall Street, and it was fascinating to actually be investing in healthcare companies. And one of the good things about being on the finance side is that you actually really start to understand how the system works, and you understand the economic drivers for why things are happening. And the main thing that I learned was that there's this massive profit incentive in our illness, and that actually all these people that when they're getting sick, there's this huge money incentive. So for instance, things like this is a really horrible flu season. So all the hospitals would make a lot of money because there's so many people coming in for flu season and coming into the hospital. So I started to just realize that there was this massive incentive in making money off your illness. And so my sister's an epidemiologist, and she studies obesity, and she would start giving these talks at UCSF about obesity in the coming crisis. And sort of at the end of my Wall Street career, I started giving these talks called How to Profit Off Obesity. And it kind of became the corollary with her talk, where we all look at healthcare and we recognize there's all these crises going on. But then I would look at it and be like, obesity is actually awesome from the Wall Street perspective. Like all these people, they're getting sick, and they're not just going to have one disease, we're going to have lots of diseases for a long time frame. So I actually took this quote from that report that I just showed you. That was a recent report that just came out 6 months or so ago. And it talks all about the various diseases that are going to profit. So you look at it and you have things like bariatric transport, cardiac care, diabetes drugs, dialysis services, emergency medical equipment, gastric bands, obesity drugs, orthopedic devices, ostomy, patient handling equipment, sleep apnea, specialist bathing systems, wound care, and others. So here you have this population of people going to generate tons and tons of needs from this healthcare system. And if I look at something like this is a map that actually starts to show how many people are becoming obese and how many people are developing type 2 diabetes. And if I look at that trend, we're having a massive growth. So again, from a Wall Street perspective, if you look at that and you're like, okay, I have now a much bigger population of people. So all of this is just good news for it. And 10% of the world is going to be obese. So again, if I'm thinking about from an investment perspective, this is awesome. And if I just look at one disease area, so this is type 2 diabetes, and it's roughly $245 billion a year that we're spending on this. So it's a ton of money. And we have 180 medicines in development. So rightfully, we want people studying this, but there's a ton of money. If you think about each of those programs, let's say on average, let's say it's $10 million. So you have almost between $1.5 and $2 billion going in annually for these experimenting on these treatments. But the thing is, as this is a quote from the Harvard School of Public Health, the good news is that type 2 diabetes is largely preventable. About 9 cases in 10 could be avoided. So here we are, we're spending tons and tons of money on it, but there's all this information about the fact that you could actually prevent it. And so there's actually this great study that came out in New England Journal of Medicine, and it compares lifestyle intervention to a drug and what one is more effective. And what they found in that is actually the lifestyle intervention was significantly more effective than the medication. And they actually even stopped the trial early because it was so much more effective. And this trial was done in 2002. So what have we done since? The CDC actually has this whole program, the National Diabetes Prevention Program, and it's a really successful program. But how much money do we as a government and society put into this? We put $7 million a year. So the budget for this year is $7 million. Now, if you compare that to the amount of money we're spending on it and the amount of resources that's going into trying to find new treatments, it's a tragedy, especially when we have the data that we show that lifestyle intervention makes a difference. So the biggest question that I learned from Wall Street is who makes money off me not being sick? And it's one of the things I started to realize, like, everybody makes money when I am sick, but if I'm healthy at 100, I don't add to the healthcare economic system. So that's a problem. And there's basic things I started to look at. I'm a woman, been on birth control pills before. A lot of you in the audience probably have as well. Were any of you ever asked to take a factor V Leiden test to see if you were actually higher risk for blood clots? Anyone in the room? So that's, to me, one of the tragedies of public health, is that factor V, if you're on a birth control pill, you're higher risk for a blood clot. And there's a test. You could get a genetic test. Some people are genetically higher risk for that. 8% of the population is. But nobody is screened because it's just cheaper to treat than it is to prevent. And I think that's a real tragedy in this system. So one of the quotes that I saw from this website, you don't get paid as much to do prevention as you do to see a sick patient. And that's actually something that has been repeatedly iterated to 23andMe. I had a physician actually stand up at a neurology conference, and he said, the biggest problem with 23andMe is you generate non-billable questions. So again, I think that that's actually a tragedy. So if anything, I'm a huge fan now of what Obamacare is trying to do, of trying to say that preventative care should be part of it, that you should be able to make money off of prevention, or off of actually staying healthy. So one thing I also want to emphasize is that the healthcare system spends $2.7 trillion. So while we're all excited about things like WhatsApp getting bought for their $19 billion, and that's huge, $2.7 trillion is a massive industry. And I had this one panic attack moment in one of my final days of Wall Street where I walked into a conference of medical billers. It was not an exciting conference, nothing compared to this. And it was a sea, it was a room like this, and just filled with people in dark coats, and all talking about how to maximize the billing opportunity when you come in. And I just suddenly realized, we make so much money off the inefficiency of the system. There's so many people there trying to make money off of those inefficiencies, it's never going to change from within. And so that is what really led me to partner up and to start 23andMe. And 23andMe was intentionally set out to change healthcare. This is not an easy adventure. I was saying earlier, if I really wanted to make money or really wanted to have an easy business, I would have opened up an awesome coffee shop or done something. But 23andMe was intentionally set out to try and change healthcare. Because healthcare, I really believe, if we don't do something dramatic, when by the time we're all 60s, 70s, 80s, the system sucks. So we have to do something to change it. So here's some of our founding principles about what we believe. First and foremost, I would much rather prevent disease than treat it effectively. And as much as I can effectively treat type 2 diabetes, wouldn't I just rather not have it? Who wants to do shots every day and take medications? I just want to prevent it. I don't want to be a 100-year-old who's healthy managed in my illness. I want to be healthy. So secondly, is that genetic information is the basis for personalized medicine. So I think you probably all hear about personalized medicine and how it's coming and how we're going to know exactly what's right for you. And the basis for that is genetic information. And when we try to understand personalized medicine, you look at a very basic example like Benadryl. Who in the audience, when you take Benadryl, gets hyper? And the rest of you get sleepy, correct? So that's an example of personalized medicine. You don't want to give your child Benadryl when you're going on an overnight flight to Europe and then find out that it makes them hyper. That would not be fun. So personalized medicine is something that's going to help us all have a better healthcare. And third is that knowing your genetic health risk will help you actually make better decisions. So that if you know that you're genetically higher risk for something, does that help you become more aware with your physician? Does that help you actually make lifestyle changes because you know that you're potentially higher risk? Does it just become one of those points where you just are more motivated? And last is this concept about big data. And this is one of the key research elements of 23andMe, where we had this idea, if we really want to transform healthcare, I want to collect the world's data. And if I can collect the world's data on our health, I can actually start to really understand why some people can live to 100 and not take any medications, and some people get incredibly sick at 40. So what is it that we can do within certain limitations to live as healthy as possible? And how do we collect all this data so we can really start to understand? And last, one of the most important points for us is we strongly believe that everyone has the right to get access to their genetic information and to understand it. So it's one of the things that's a Tor pen. It's your data. It's all about you. Imagine if someone told you couldn't look in a mirror. It's your information and it's yours to have. So how does it work for people who don't know anything? It's an entirely online service. So you go online, you order a kit. You order a kit, you spit in the tube, you mail it back to us, and anywhere from 2 to 8 weeks later, we send you an email that says, welcome to you. So it's not done through a physician. It's all entirely online. So what is it that you can learn from your DNA? So there's 5 areas, really. So first is what I mentioned before is the drug response, medication response. So we're starting to understand, and the FDA actually has this whole long list of medications that have a known drug response. Second is things like disease risk. So we've all heard about Angelina Jolie having her BRCA and being higher risk for breast cancer. There's other areas, things like I mentioned before, this factor V Leiden being higher risk for blood clots. And then there's things like inherited conditions, so things like cystic fibrosis, which you've all probably heard of, and there's a whole long, long list of other inherited conditions. And then last, it's things like inherited traits, things like lactose intolerance, and then other exciting things like, we've been well known for this, for the asparagus and the urine question. So some people eat asparagus, and they smell it in their pee, and some people do not. And no, you don't have to get really close to sniff it. So who has no idea what I'm talking about? Come on, admit it. Okay, a few of you. Yeah, so we can all make fun of you. About 30% of you in this room have no idea what we are talking about. And the reason why we have things like inherited traits is because it's the fun aspect of humanity. It's that long tail. It's interesting. It gets people talking about it. Because if I came to you and I said, I want to talk to you about the latest discoveries in Parkinson's disease, you're probably not going to really grasp onto it. But when I start talking about asparagus and pee and the photic sneeze response and sort of like interesting traits about you, people get excited and they remember it. So last, one of the really fun aspects of what we do is this ancestry, and I'll talk about that a little bit more. So first and foremost, I want to just give the disclaimer that we are no longer providing you with your health information. So we got a letter from the FDA on November 22nd asking us to stop, and we have complied. So we are no longer giving that information. So I'm going to talk about a couple stories to sort of illustrate about what are the types of things that people have learned before. So after this letter, one thing that has become very clear is just how controversial this is. And it's really evoked a tremendous amount of press and a tremendous amount of discussion in the community. So it's one thing that we've realized is that genetic information is sort of reaching that critical mass where it is coming. And lots of people are discussing what is the right way for us to be using this in society. So there's been tons of literature work in all the major papers, JAMA, Nature, New England Journal, et cetera, talking about what are the academic opinions about 23andMe and how we should be using this. So one thing that I want to emphasize is as much as we're sort of stuck in this debate, the rest of the world is moving forward. There's a great article in the New Yorker by Michael Spector that talks about Beijing Genome Institute and what they are doing. They are the largest genetic testing company in the world. They are doing a ton of sequencing. And China is doing a ton in genetics. So not only China, but Saudi Arabia, the UK, Scotland, other countries are all doing a lot in genetics. So it's kind of a question that genetics is going to become part of our daily life. So that's what I just want to really emphasize into you, is that as much as we're sort of debating this right now, genetics is becoming incredibly cheap. Getting your genome is going to be incredibly inexpensive, and it is going to be part of your daily life. So after 6 years of operating, we've been able to get hundreds of stories, from the health side to the ancestry side, et cetera. So I'm going to do a quick video for you guys that talks about some of our stories. But
people don't realize what a profound effect your genetic code can have sometimes on your behavior.
You don't limit the knowledge of who you are, where you come from.
It really changes the way you look at your past, how you live your life right now, and how you see yourself in the future.
All it takes is a little bit of small changes here and there to just make for a better, healthier life.
The information was there all the time, but I just couldn't read it before. You know, someone's just translated it to some results on the screen.
And then when I got my results, I ran down those stairs and I was like, look, I said, we're cousins.
I finally made the connection of who I am.
This is life-changing information that I think it's amazingly powerful information. I feel very, very lucky.
And I love that our answers, our feedback, we knew was going back into that data pool to help make that information more valuable.
Why would I not do this, to be a part of something that's so much bigger than me and what it's going to tell me about myself or my family?
So I'm going to go through then a couple of our health stories that we've heard. I can get. It's my first time ever showing a video. Oh, good. So this is Kristen Whitaker. Kristen, we have a number of these testimonials, and Kristen is somebody who came, she'd had 15 years or so with severe stomach problems, seen tons of doctors about it. Nobody really knew what it was. She ended up having 3 kids. One of them also had a lot of stomach problems, and very randomly she started seeing a doctor who told her to get genotyped on 23andMe and found out that she was actually significantly higher risk for celiac. She went and then got tested, and it turns out she actually did have, she had got the blood test and then was scoped, and actually that she did have celiac. And so she comes and she says, like, for the first time her daughter is actually growing. She wasn't growing before. She's happy, she's in school, and that they're actually not in pain. And that, again, sort of the message there was sort of, as much as 23andMe, the celiac report, is going to tell you if you're a higher risk for something, but then partnering with her doctor, it was another clue to help her figure out what it was. And so a lot of physicians, obviously for the 15 years, had sort of overlooked this concept of, okay, let's test her for celiac. And so 23andMe is sort of that helpful tool to potentially help think of what other ideas, what is it that you're at risk for. This is another story that came our way. Pseudocholinesterase deficiency is something that was also on, or it is on the 23 market, not giving the result back now. But pseudocholinesterase is an anesthetic that is frequently given if you're getting mouth surgery, or it's a short-acting anesthesia. It's a short-acting muscle relaxant. So nobody loves going to the dentist and being drugged. And that sort of image is always terrifying. And then Daniel MacArthur wrote actually this report. He's a professor at Harvard, and he heard from his friend about this patient who showed up for emergency surgery. She had had her wisdom teeth out, emergency surgery, and she actually came with her 23andMe report saying, I have this pseudocholinesterase deficiency. And that because of that, if she had gone on the medication, she potentially would have been out for hours versus the 3 to 5 minutes that it typically makes you sedated. So if you think about, if you're typically sedated for 3 to 5 minutes and your doctor's expecting that and they take the tube out and you don't actually wake up for hours, that's not fun for you and it's not fun for the physician. So preventing that is hugely helpful. And the thing that's amazing to me is that 5% of you have this variant. So I don't know if anyone in the room know that they have it. I don't see any hands. But 5% of you, there's some of you in this room that do. And so this is, again, sort of that message of the prevention. Having the information is helpful, whereas normally anesthesiologists just sort of ask, is there a family history? Has anyone ever had anything like this? And that's how they sort of start to do the testing. This is a guy that I recently just met. He met me at a healthcare conference in January, and he came up and he's like, thank you so much to 23andMe. He's like, I have this 7-year-old son who for years hated everything like ice cream, cookies, fruit. He's like, it was a problem. Like, we'd take him out and he never wanted to eat any of this stuff. And we took him to tons of doctors. They couldn't figure out why. And he's a CEO of an investment firm in healthcare. And so he got tested on 23andMe, and he's going through his results on his iPhone. And all of a sudden he sees that he's a carrier for something called fructose intolerance. And he then suddenly took the light went off. He took his son to the physician, and lo and behold, his son was actually fructose intolerant. And the problem with fructose intolerance is it's not usually diagnosed until much later in life when you actually already have some kind of disease. Either you can have liver disease or kidney disease or both. And so he's really grateful that he says, well, thankfully his son, who was only 7, is now able to change his lifestyle, prevent eating a lot of sugary foods, and will no longer is able to prevent having those diseases. This guy I was on a panel with on Friday, and he didn't know I was speaking at the conference too, and his entire talk was about 23andMe. So he's actually a real doctor. People really go to him. He's in Vegas though, so of course he has to also have sort of a comedic side, and he actually is also a comedian. And he's a physician, his father's a physician, so you always think if you're a physician, like, geez, you must have the best care because you're a physician. And he gets the 23andMe report, and lo and behold, this factor 5 that we talk about, the blood clotting, he actually has 2 copies of both for this factor 5, factor 2, and he's super high risk for blood clots. So he has this panic moment. He calls his dad. His dad's like, don't worry about it. He's also a physician. But then he starts digging. He's like, Dad, tell me the family history. And his dad's like, oh, yeah, your uncle died of a blood clot, and, grandma died of a blood clot. And he's like, dude, everyone has died of a blood clot. Like, why aren't we doing something about this? So he's like, here I am, I'm a physician. He's like, I have super high odds. So anybody who has a report like this, you know what you can do? You go to your boss and be like, I am only flying in first class, because you need to move around on an airplane. So he now takes a baby aspirin every day, but he's able to be proactive because he has this information. Jonathan Zittrain, somebody who frequently comes to South by Southwest, he's a professor at Harvard, he also found he was a carrier for the factor 5. And he had randomly, in the middle of the night, started having these night sweats, having pain, shows up in the emergency room, they do the scan, and he has a giant mass on his liver. It's like, oh no, this is horrible. Giant mass on liver, most doctors start to think that it's cancer. That's not fun. And so in his sort of physician haze, he starts to suddenly remember. He's like, well, I have my 23andMe report, and I'm a carrier for factor 5. And lo and behold, it kind of turns out that this is just a giant blood clot. And so very different than cancer, obviously. It's still not fun, has to be taken out, but very different prognosis than cancer. So again, it was a really helpful clue for his care. And again, it's that clue, because physicians have a really hard time knowing everything. It's hard to be the perfect clinician. So getting more clues was just incredibly helpful. And last, we have Jennifer Goldstein. So Jennifer actually found out that she was a carrier for BRCA, BRCA through 23andMe. So this is one of the more controversial reports where that tells you if you're higher risk for breast cancer. And she is somebody who didn't know that she was at risk. She was never looking around to find out if she was a carrier for BRCA. She was totally surprised by the report, and she, lo and behold, she partnered with her physician. She got repeat tested with another company, and the physician concluded that it was in her best interest to go ahead and do a double mastectomy and take out her ovaries. So again, part of what she said, she's like, by getting this test, I never would have known I was even at risk. And the important thing is always for the consumer to partner with their physician and figure out what to do next, and that's what she did. So one of the things that we actually did start to study is exactly that concept. For people with the BRCA variant, what did they do with this information? And we found that most of the people who found their BRCA carriers through 23andMe were not looking for that information. So it was sort of a surprise. And that they did then go and partner with the physician, and they actually take appropriate actions. So it's a Nature paper that just came out. And the thing that I love about this is that it talks about how people come in and they want to make a change. And what's challenging in healthcare is finding that aha moment of when do you actually want to change your behavior. It's a really tough time to actually get patients to change. But what we're triggering is people coming in saying, I want to change. Help me change my lifestyle. Make changes in my life. So it's an opportunity for physicians to potentially really embrace this and say, let's have a dialogue about what are things that you could do. So for all this that we're doing, you question how much is this costing? And this is a really important point for me. 23andMe is a direct-to-consumer company, and our goal is to make healthcare affordable. So we do not go through insurance, because if we had a middleman, it would only be more expensive. So the product has been $99. We have dropped healthcare, we've dropped the cost from $1,000 to $99. I actually even had one senator tell me that they thought we were sort of snake oil company because healthcare costs only go up. And the fact that our costs have gone down is very suspicious. So again, it's one of the things, like, I want to have a different system. Healthcare should be affordable, and we can make this technology affordable. On the contrary, one of my colleagues in the office went and he got tested through another company, through his physician, and for a subset of what we test for, these are roughly 8 reports, and you can see how much they all add up to. And it was $1,400. So the insurance company paid $1,400. So if you think about sort of the waste in the system, we're a $99 test. Healthcare should be able to be affordable. But the system just paid $1,400 here. So it's part of what I'm eager to change is more and more things should actually be in your range where you can just pay out of pocket. So I'm going to then move to not only do we do the healthcare side, or did we do the healthcare side, but also the Ancestry side. So this is my friend Monica. Monica, if you look at Monica and you try to guess sort of what is her background. So we can sort of profile, she's obviously partly African-American, but it turns out that she actually had this really diverse background where she's roughly sort of a third African, a third Asian, a third European. And so, lo and behold, Monica knew some about her background, but suddenly she has this rich depth about where she's actually from in the world. And it's super cool. I actually put up once her slide without her picture, and someone shouted from the crowd, "Is she single?" No, she's now married. So here's another way of looking at her painting. Each of the different colors represents different parts of the world. And as our database grows, we're able to tell people better and better which parts of the world they're from. So one of the most fun aspects, people always want to know if they're Native American or if they are Jewish. And so this is a slide. If they're dark blue, that is sort of the Jewish component. And I spoke last year at this convention of Reform rabbis, and I presented this, and I was like, hallelujah, like all these people are going to be coming in to your congregation and being like, I'm Jewish. What are you going to do? So that was sort of one of their big ethical questions about what are they going to do with all these people. So these are all these people now thinking like, hallelujah, I'm Jewish. What do I do with it? So the other fun thing we have is the Neanderthal side. And again, you can compare with all your friends. You see this tweeted a lot. Again, it's one of those things like it teaches people about genetics. And it gets them excited and it gets people coming back over and over again. So you can see I'm sort of I'm actually below Neanderthal. So I don't know if that's good or bad. My family might have an opinion. And then we do some other fun things. Like you can actually start to trace and see where your genetics go. So this is my son's eyeball. And I can actually see which parents it came from, which grandparents it came from. So I showed it to him the other day, and he was like, no, my eye is my eye. And I was like, no, your eye actually came from these grandparents. But it's pretty cool for a kid to be able to look at that and start to understand their genes. And this is my daughter. I don't tend to show pictures of my children. But this is kind of her genetic makeup. That's the 23 pairs of chromosomes and the compilation of how each grandparent contributed. So when she's acting up, I can be like, it's so annoying, chromosome 1, it's really overacting. That's all from my mother-in-law. And then I can also look at the percentages, and I can be like, whoa, my father-in-law is very aggressive, and it shows up in the genome because he's dominating at 60%. My mother, if anyone knows her, she's very active in this community. She's also very aggressive, and she's 55%. So it's kind of cool to see how much what your kids' genomes look like. This is a story also of people who, we have something called where people can connect with each other. And this is Neil Schwartzman, I think. And he was adopted, was always looking for a sister. And lo and behold, on 23andMe, he suddenly gets this, he looks online, he sees someone that's a first-degree relative. So his sister never knew that she had a brother that was given up for adoption. And it turns out they actually live in the Bay Area, and they're now good friends, and they hang out. But through 23andMe, you can actually find other individuals who are relatives and connect. So now we have 100+ of these stories of people finding first-degree family members. So that's his quote. And I think this is a really fun part, is somebody who was adopted wrote in talking about how, for years and years they knew nothing about themselves and suddenly have this giant pile of information. And that's really what's fun about your genome, is it's just sort of that digital manifestation of you. It's just a different way of understanding yourself. And so suddenly this giant pile of information can enable people, especially people who are adopted, to really learn a ton about themselves. But along those lines, we do give people a ton of information, but there's a huge research component that we still have because we really don't understand that much still about the genome. And so one of the things, the inspirations I have is actually this Target story. For those of you who don't know, Target actually had this whole story about how they were able to figure out that this girl was pregnant before she knew or before her father knew. And they can do that because they have so much data about everyone's shopping patterns. And obviously Amazon does this because they have so much data about shopping patterns and what people like and what they don't like. But wouldn't it be so awesome if you had all this data about you and then you walked into your doctor's office and they're like, oh, you're really like, based on all your exercise and your eating and your other patterns of where you live, you're 5 years away from being diabetic. You really got to change this. Or you really need to make these types of changes based on your actions. So it'd be so cool if you had that data to actually change your own health. So this is the research that we're doing. We combine your genetic information and we ask you to take surveys. All kinds of different surveys, from things like Parkinson's disease to commonly used medications to more controversial topics like sexual orientation. So tons of research. And here's a quick video about how we actually are from our scientists, who are all awesome.
We try to take a really broad view of medical data, and we look at things, anything from really serious conditions like Parkinson's disease, cancer, to more common but maybe less serious conditions like migraines or allergies. And so at any one time we may be studying hundreds if not thousands of conditions at once. Because it's relatively easy for our participants to contribute information to research, we can look at a really wide range of conditions. We have an opportunity to look at the breadth of things that the government just can't cover.
The big difference between 23andMe research and research at other institutions is the scale. We have so many people participating that we're able to make discoveries in topics that would not be available for research in other institutions. Most clinical research projects will just focus on a single topic, whereas we have ongoing data collection on many topics with very large samples of people.
A company like 23andMe needs to exist, because if it didn't exist, we'd still be talking about 10 years in the future. We know that there are huge amounts of heritability hidden in the genome somewhere. We know that there has to be something that we can explain for these common diseases using your genome. And once we have figured that out, it will be the primary tool that's used to drive your healthcare.
It's my science team. They're awesome. So why do we do this research? So first and foremost, we want to understand, is there a genetic basis for disease? Because if you have a disease, if you have migraines, you have multiple sclerosis, whatnot, you want to understand, why do you have this? Is there a genetic basis for it? And are your kids at risk for it? Oops. Second, going crazy here. Second is, do some medications work better than other medications? So again, going to that example that we had of the Benadryl, like, you want to know, like, not all medications work well for people. So do you want to spend all that money? It could be hundreds of thousands of dollars on medications. Do you want to actually take it? Or do you even want to go through that pain of actually taking medications that are not working? So how can we understand that? And then last, by having all this information, can we help be part of the process of developing new therapies? So as an example of that, which emphasizes why it's so important to have so much data and why it's so important for all of you to be involved, is a study of something called PCSK9. So this is a new therapy that came out, and essentially or a new discovery that came out, and essentially what happens is, healthy, fertile woman came in, and turns out that she actually had 2 copies of a mutation in this gene. And as a result, she had super low LDL levels, and you want your LDL to be low. So they started researching her, and they found out that it was a mutation in this gene. And as a result now, today, I forgot what year that was 5-6 years ago, there's now 5 medications in development targeting that gene. So again, all because this one woman came in and they started researching her, why is her LDL so low? That then became like the light bulb went off for all these people to study and research and say, that could actually be a drug target. So this is an example of when I got sequenced for myself. This is from another talk I did called Deleterious Me, where like these are the 100 mutations I have where I theoretically don't have those genes turn off. I have a loss of function, and any one of those reasons I could be dead. But I'm clearly not. But it's interesting to study. Sort of like, to me, this is the long tail of humanity. Why is it that we're all slightly different? And it's because we have these mutations, and because we have these mutations, and because those all make us sort of unique. But the advantage of that is that we're all special, and we could all be helpful to that drug discovery process. So 2 ways that we actually do research, things called GWAS studies, genome-wide association studies, where you actually look at the disease and you look to see are there genes associated with that disease. And then secondly, things called PheWAS studies, which is where you take a specific data point in your genome and you look to see what are all the other phenotypes or the other traits that are associated with that. And so in my genome, I have, this sort of breaks it down. Oh, I lost that one. The top 4 categories are all sort of known as the variants of unknown significance, meaning that we really only know about a fraction of what the genome means. So we don't know about much what most of the genome is doing. So how are we actually going to figure that out? And this is a real-world example that came to us where a family came and they said they had 3 members of the family who all had pancreatic cancer, and they got sequenced by a number of different groups. Tons of people analyzed the data, and they found that there was a variant in a gene called MLH1, which is traditionally hereditary colon cancer. And so they came to 23andMe and they asked, how can we figure out if that's actually the variant that is causing that? Because they wanted to do millions of dollars of follow-up studies with an academic group, and they weren't sure they really wanted to invest that money. So first thing 23andMe did is we found that we had 157 other people who have that same variant. So we then put out a survey about cancer risk to see, or cancer family history, to see if they've had cancer themselves or if there's a family history of cancer. And we sent out an email targeting people, and in 12 hours, we had 12,000 responses. So again, for people who know anything about research, to get that kind of volume is phenomenal, because most clinical trials, you try to get a couple hundred people, it takes years. And what we found here is that most of the people who have that variant do not have cancer. So therefore, very quickly, we were able to conclude that this family that thought that they had this variant, they knew what the variant was causing the pancreatic cancer, we're very quickly able to conclude that that is not, in fact, the variant. So the current system, how they normally would have gone, it would have taken, if they applied for a grant, most of those grants don't get funded, and it's a huge amount of time before you can actually get to the answer. And so it's part of this whole quote, it's part of the reason why we have, we're trying to figure out ways that we can actually make this whole database more accessible. So one important thing to note is we have 650,000 customers now who are part of 23andMe. So by far and away, this is the largest database in the world of individuals with their genomes. We have 175 million questions that have been answered by our customers. And 40% of individuals are coming back to the website regularly. So one of the things that we're trying to do now, because we have so much data, is we don't just want the 23andMe science team being the only ones to access this data. So we've launched something called the 23andMe Research Accelerator that will enable researchers all over the world to get access to this data. So this is sort of what it is looking like, where very quickly you can almost answer questions the same way I showed you in that pancreatic cancer example, that you can almost have this real-time research. So where's the future going? I think one of the most interesting trends for you guys all to be aware of is this notion of the consumerization of healthcare. And that for the first time, people are starting to recognize and accept the fact that healthcare needs to be driven by the consumer. And you can all take control of your health information. And just as a reminder, not that long ago, back in 1961, there's a study that came out where they interviewed physicians, and 90% of physicians said if they saw a patient with a cancer diagnosis, they did not want to tell them that they had cancer, which is kind of shocking in this day and age. So HHS, Health and Human Services, just came out with this announcement saying that patients now have the right to ask for their lab reports without having to go through a physician. So again, more and more, you can be in control. You can just go and directly ask for your lab results. There's something called the Blue Button Connector. You can all now go, all of your insurance companies and your electronic medical records should have an easy way for you to download your entire medical record. Information suddenly about cost is also coming out. This is a phenomenal article that came out in the Washington Post talking about how if you want to do something like get a pacemaker, the cost could be a difference of threefold depending on where you go. And I just love this quote. For the first time, the government has released prices that hospitals charge for common procedures. Until now, it was a competitive secret. I mean, it's kind of crazy. Like, who would go to a restaurant and be like, it's a competitive secret how much our chicken saute is? Like, that's crazy. And you're starting to have clinics pop up where the information is all just right on the wall. And so for 23andMe, we are firmly focused on the fact that the genetic information is yours. And we have launched a program where we have developers building out on our API so that lots of different programs can be built with the genetic information. So I'd encourage all of you, since this is a very real developer crowd, think about what are some of the interesting apps that you could actually have with your genome. So with all this data, what are we going to do? And again, just to emphasize, this is really my goal. Like, how can I be this awesome woman? She's 92. I can't even do that pose now. So how can we all actually be healthy at 100? So just to conclude, my last main point here is you should own your data. We're at a point where we can actually have a real revolution in healthcare. And it's only going to happen if you actually all stand up and you demand it, and you ask for it, and you do something interesting with it. So with that, I'm going to end. I'm going to have Kara Swisher come on, and we're going to ask some questions, and we're running a little behind. Sorry. Don't yell at me.
Should the guidelines change? Is the FDA moving fast enough on these things?
There's a lot of interest in changing the guidelines to become more accommodating with full genetic data.
And what does that do to your business when you're like this? Where are you right now with those, in that area? What do you have?
So having the FDA come and shut that down has had a significant impact on the business.
So explain that. What does that mean?
I think it definitely, I think people come, they want to know on the Ancestry, they want to know on the traits, but healthcare is people, I think more and more, one of the things that we did with the advertising campaign and whatnot is we got people excited about their genome.
Right.
We have a course with Udacity, 13,000 people signed up in a matter of months. People want to know about their genome, and they want it interpreted. Right. So I think it's had a significant impact where people want this information.
So how does that logjam come through for you? What happens now to your business?
I think I'm thankful to my team. I think we all have a real, we're used to being, we've had a lot of ups and downs in this, and we recognize that we're pioneers. And so we just have to have that tenacity to push through it.
So does that mean the planes are going to be covered with the bodies of those pioneers, or what?
No, not quite. But I think that we to be honest, I think it's going to take time and money and effort to figure out exactly what the path forward is going to be.
Before we move on from this, how does that affect your business? What does that mean? Is it less interesting, or people have less information, and will they ever be able to get that information back?
I think it's slowed down the number of people who are signing up now. But to be honest, with 650,000 people in our database, we are inundated with academics, pharma partners, countries that are interested in leveraging that opportunity, because it's more data than anyone else in the world has.
So where does it go when there's a lot of questions. There's a question here from Twitter. Through 23andMe, you have been interested in epigenetics, control above genes.
Yeah.
What do you, talk a little bit about that
So I
issue.
think one of the things I wanted to say actually at the end is that I think 23andMe right now focuses on SNPs in your genome, but I think at some point it's going to become, we want to enable you to get access to all the data that you want. So epigenetics is not something that we are doing now, but as technologies become standardized and that they're they're more reliable for a consumer, we'll consider adding on additional types of tests.
Such as?
Such as, I love the microbiome. My research team always pushes back on this, but the microbiome, really understanding what your gut bacteria do for you. So for instance, it's hypothesized that I don't have any cavities because I have a certain kind of bacteria in my mouth. I don't know what your bacteria in your mouth is like.
A lot. But that's on purpose.
But we have different, yes.
So this can lead to this sort of idea of what control people should. You were talking about people having total control, but in total control, the issues of privacy come up, that people have all this information. One branch of that is they have too much information, and so you get into, do you need all this information about yourself, and does it create problems in that regard? And the second part is that insurance companies, Google, which is one of your investors, I don't love Google having every single piece of information, including my gut bacteria information, because somehow they'll monetize it. How does that? They could. They could. And they're an investor in you. How do you look at this? Because let's start with that privacy side. Where does it go when when this information is out there? This is. This isn't who you're dating. That's what.
One of the reasons why we intentionally went direct to consumer rather than through insurance companies is because then you own the data. So whoever pays owns the data. So if your insurance company pays for it, then they would technically own the data. There's now things like the Genetic Information Non-Discrimination Act, so it cannot be used against you. But we still feel very strongly that it's very personal to you. You should own the data. And
Right.
so if you want to share it with your mother, you want to share it with me, as you did, like share it with others, then that's your right. And most tests, like how many people actually share their blood tests with anybody? No one. So it's kind of more like our definition of this privacy has been really about you control the access and the data points. So you want to share it with your physician, you should be able to do that.
I'm talking about unintended consequences, because as people begin to share, they share everything now and they feel very comfortable. These are very serious things. If you have a proclivity for obesity or cancer or anything else, it becomes something a little more serious than you're on Snapchat or you're on Tinder or whatever. It's a very different kind of piece of information than that if you go to the Target and buy these shoes, or you go to Amazon and buy this. It has unintended consequences. Do you think about this idea?
I think we think about it a ton, about the privacy, and we've built the systems in every way to make sure that we can do everything we can to protect your privacy. And we've always felt that the company has no foundation if we can't actually guarantee or do everything that we can to protect your privacy. So it's important to us, but what we find overwhelmingly is that people do want to share this information. You're not going to put your obesity risk on Facebook necessarily, but you might share that with your physician, you might share it with your family. And so enabling that, I think that everything is going to be a risk benefit. And I think that overwhelmingly what we found is that people are more willing to take on the risks because they feel there's a real benefit to actually enabling more people to get access.
So this is an interesting question related to that. Shouldn't you be paying me for access to my DNA data instead of me paying you?
So, that's actually something that we get questions about a lot. I think it's really important to remember we are providing a service for individuals to really learn about themselves. I think that there's a huge benefit of the aggregate data, but an individual genome itself is really valuable for you, but it's not valuable. I can't go and try to monetize an individual genome. It's that aggregate data, and it's the combination with all of the phenotype information. And so I think it's always something that's a concern, and we try to be really transparent about that as well, is say, if you don't want to participate in our research, you don't have to. But when I get people, we have a sarcoma community, when I get people with sarcoma who come in, they're just begging, saying, like, you should do as much as you can with my data because I have a fatal disease, and I'd like to do as much as I can that's going to help me or help my next generation.
Right. But I think, again, that's true. When you have certain issues, you want to have as many people in the group as possible. Again, I hate to go all Gattaca on you, but the idea, there is this sort of darker possibility with all this genetic information, including the ability to manipulate genes and to get rid of them. There's been innumerable plays and fiction about this concept. Do you think about that, where it leads, like what happens when you get into because eventually this quantification of self is going to be almost complete.
So I think it's something, again, I think it's one of the interesting things that was in that New Yorker article where they talk about what other countries are doing. And I think that having society, like recognizing genetic information, I think is going to have a tremendous amount of benefits for us. But there's a real need also for the ethical, legal, social groups to be talking about what are those restrictions. So, embryo selection is definitely one of the big questions. How are we going to manage that? But if I can use your genetics and I can have, single cell sequencing technology and I can detect cancer much earlier, like, the risk benefit, everything is going to be a risk benefit. And I think really just society, I think, needs to have these debates. I think there has to be various laws in place, or society has to decide what are they willing to accept. But overwhelmingly, I think that having broad genetic information out there is going to be a net positive.
What about the accuracy of that data, too? That's another issue, because there's been controversies around that, especially because it's a private company. You're a private company, presumably trying to make a profit at this. Accuracy about these reports is going to be questionable, and I think there have been some issues around what is positive, what isn't. There was one
there's been reports. So, and I should emphasize, the one thing about the accuracy, 23andMe uses the Illumina technology, and we use a SNP-based technology rather than a whole genome, which means we're looking at variants in the genome. We use that technology because it is so incredibly reliable. It is a gold standard. It is a phenomenal technology. It has a 99.99% reproducibility. It's a phenomenal, inexpensive technology, and that is why we went with it. So when I tell you that your call is an A, I have a very high level of confidence that at this point in your genome, that A is right. Where there's been some debate is when I tell you your prostate cancer risk. If I say that here's the literature and here's all the different SNPs about it, what each group is using from the literature can vary, and exactly how big those studies have been and how accurate is that point about if I tell you it's a 45% risk or is it really a 55% risk. That's where this big database is really going to help us really understand what is that true meaning of that variant. So the calls, we have a very high confidence in that accuracy, and I think that's where more and more on the disease risk, it's evolving. But on something like cystic fibrosis or the BRCA variant or the factor V for blood clotting, those are really well established. And then there's a giant research section where you say, we're still learning about that information. And I think more and more, that's where we're going to get that data.
And in that case, given you're a private company, funding from venture capitalists in Silicon Valley, from Google, what are the worries, if you were not you, that you would have from that, from what happens to your company if it doesn't continue, where the information goes? Who really does own it if something, say, happened to 23andMe?
So what we've said is individuals always have the right to download their raw data. So anyone out there could go into 23andMe, download their raw data, and give it to anyone else they want. So there's other services out there, for instance, that will do an interpretation of your genome. So you could take 23andMe, download your raw data right now, and upload it into other places. And again, we've always felt strongly that your DNA is your DNA.
So, okay, that makes it clear. So we have just a few more seconds for a question. I'm sorry, we don't have much time, and we have a certain amount of time we can talk. But when you think about your business, I know, how do we support you? I don't know what that means. Can we go to the next one? I don't know what that means. It means personally.
How you support? No, I mean, I think that there's been, like, the FDA has come in, and it's definitely been, people are passionate about trying to change healthcare. And I think that more and more, if people want to do something, the most proactive thing that you can do is actually start owning your data. Get your full genome, download your data, share it with other people, talk to your doctors, use the other services, get your blue button data in your full medical record. Like, really be part of it. Like, own it.
Last question. Where do you imagine your business going? Are you worried for your own business? And then if not, where do you imagine it? What does it evolve into from your perspective? First, talk about your business. I mean, because
I think that what the potential for 23andMe is really to massively change the way we are approaching our own health in terms of a prevention side, and really changing the way that we're doing research. And I hope that in 10 years that we can actually have much more of a society where people are proactively managing their health, that they're actually getting information that helps them avoid disease, and that 23andMe becomes a platform that's working with everyone in academia to pharma companies to everyone around the world, so that we can help dramatically accelerate the pace of research. And I think that's where, there's a net benefit to us. If we can actually really improve the flow of how people are making discoveries and the research, and we can kill drugs that aren't going to work well much faster, or if we can really understand medications that are going to work for smaller groups, just really changing the research paradigm. Put $60 billion a year into research. And I think there's a massive potential for us to make the entire system much, much faster and much more efficient.
And should we leave that to private companies like yourself to do that?
I think one of the most important things that 23andMe needs to do, and that we are doing, is enabling the broad access. So I think it's, it's a question of...
I'm sorry to harp on it. It's just,
it
creates a fearful situation where private companies do run genetic information.
Right.
And that
I think the most important thing to me, and I think the words that we really try to live by, is the transparency. And you look at examples like this, Henrietta Lacks in the Gila story, and how they took her ovarian cancer cells and they sell them all over the world. The biggest problem there, I think, is that there wasn't the transparency. But if I took
they lied to her.
They lied to her, too. Yes, well, more than that.
My point being is, it's often found people lie to you about these things, and that you don't know what's happening, you don't get full access, and people are confused by it. And this is not, again, you sharing a photo, or you're talking about your drunken escapade at South by Southwest, not that happened here at all, but that it's very serious information. And I'll just very briefly before we end, I had a medical encounter, and you knew about my whatever thing I had, and it helped. That said, it was a little frightening to think about that, that there was genetic information about me available. Now, I allowed you to see it, and it helped me in my medical treatment, but it definitely brought up wow, this is something that I don't know what I think about, kind of thing. So that's what I mean, trusting, not that you're lying, but that lies have been said in this whole area.
So again, I wouldn't be doing this if I wasn't such a believer in the potential of genetic information to transform society. And I think that the most important thing for this company is to always be transparent. And for instance, if you were the woman that had that variant that led to all those new therapies for reducing LDL, you should know. And you might celebrate that. You might be like, I'm Kara Swisher. I have a whole new, I spawned a whole new drug development unit.
I doubt it. Okay.
Possible, but like everyone's interesting. Like you don't even know. Like everyone's interesting for some reason. Like your data might be incredibly valuable, and then it's our job. I want you to actually know that.
Yes, that's true. But sometimes it makes you feel like I'm on the Matrix and I'm in a pod and they're sucking me for energy.
Well, I think that's also our job as a company to make sure that people feel that they can trust us and that we're always transparent. It's a partnership, and I think again, like we have had times where customers will be, you know, we had a subscription model for a while and we changed it, and we had customers who were really aggravated and said they were going to walk with their data. So it's one of the most valuable things, again, we do is we enable people to shut down their account, download their data, and leave. And I think that keeps us in a really constant interaction with our customer, because we will only be successful if we have the trust of our customers. Because so much of what we're doing depends upon us. Like, I want to ask a questionnaire and then ask you questions. And if you don't trust us, you're not going to take those questions. So we have to repeatedly show to you that we're doing the right thing. And that's why we publish. That's why I feel really strongly, like, I don't want to treat you like a human subject. I actually want to treat you like you're a consumer. No, but I mean, a little bit. Like, we have an IRB-approved protocol, and I want to protect your privacy, but I also really want you to know what we're doing. Whereas, like, if you participate in a clinical trial at UCSF and they take your data, you have no idea where that's going to go. And I think that's where we are trying to change the research paradigm to say, participate in research, but I'm going to tell you what types of things we're doing with it. And so I think more and more we want to be able to really enable people to be excited. If I look at the enthusiasm of Susan G. Komen and Livestrong and people who want to participate in research, there's massive enthusiasm. People want to help each other. So more and more, if I can just tell you, like, wow, Kara, like you took this survey, that'd be great. Or if I had, you know, a child who was sick with something and I said, Kara, like, I know you're on 23andMe, will you take this survey about this disease because you're a healthy control? You'd probably do it.
Yes.
So it becomes just an easier way for us to do research in scale.
Right.
So, and I recognize, like, part of the reason...
I guess I'm more cynical than you about where
I like your questions because I think it's exactly the type of debate. Like, we need to be able to flesh that out. Like, what are the concerns? How do we manage the privacy? How do you, you know, what are the limits of society? And that's where people need to debate that. But overwhelmingly, again, just emphasize, like, I really believe there's a massive net benefit versus the risks that are going to come from having genetic information everywhere and combining that with your data.
Okay, great. Well, thank you, Anne Wojcicki. Thanks.